There are several chapters like quantities, units, dimensions, one-dimensional motion, two-dimensional motion, but I shall start with the chapter of vectors. Now, there are two types of quantities. This is not
Scalar and vector.
two types of quantities. First is scalar quantity, and second is
Vector
quantity. So scalar quantity and vector quantity, they are both quantities. Like if I say mass or length, okay? Mass, length, weight, force, velocity, speed, all these things are put in two categories. Either they will be put as a scalar quantity or they will put as vector quantity. There is another one, but that we are not going to discuss, okay? You leave it. Example, length, mass, speed, distance, work, etc. Okay? Vector quantities, these are the quantities that have direction also. You see, mass doesn't have a direction, speed doesn't have a direction. Okay? You might wonder why speed has a direction. No, that is velocity. So we have vectors. Example, in place of length, we write displacement. Displacement, velocity, acceleration. I'll write in short, acceleration, force, momentum, torque, etc. There are hundreds of scalar quantities and hundreds of vector quantities. Right now, we are going to distinguish between the two. Scalar quantities will be added or subtracted or multiplied by their own rules. Vector quantities also will be added or subtracted or multiplied by their own rules. They have different rules. Okay. So, when you have different rules, you have to study them differently. Today, I am going to discuss only vector because scalar quantities you have been doing. Adding 5 meter to 9 meter, two lengths, 5 meter and 9 meter. What is their sum? Their sum is 14 meter. It is so simple. Their sum is 14 meter. You don't have to do anything. That is arithmetical calculation. But vectors, the sum can be 0, the sum can be positive, the sum can be negative. It all depends on what is the orientation. Okay. So, example, say 5 Newton is acting this way, and on the same point, 9 Newton is acting this way. This force is 5 Newton, this force is 9 Newton. What is the net force? Net force is 9 minus 5 is equal to 4 Newton. You can see yourself, 9 and 5. So the difference is, addition is 4 meter. This and this together, they are 4 Newton. And tell me about this. 5 Newton, 9 Newton. What is this? They together are 14 Newton.
14
that
Newton.
comes 9 plus 5 is equal to 14 Newton. So you see the difference, 4 Newton and 14 Newton. But suppose this 9 and 5, they are like this. 5 Newton and 9 Newton. Then what is their effective value? The effective value is root of 9 square plus 5 square. 81 plus 25, that is root 106. That comes to 10.3 Newton. You see the difference? Two quantities, 5 and 9. Rather, two forces, 5 Newton, 9 Newton. They are in this direction, then their effective value is 4 Newton. They are like this, then the effective value is 14 Newton. And they are like this, then the effective value is 10.3 Newton. So, it has become a very strange case. In next classes, after this, in one of the classes, I will tell you how to do quick calculations. This 106, if you do the square root, you will find it is 10.3. So these things we will tell you, but right now, today, what are we going to do? We are going to study vector quantities. So before that, I have told you what are the vector quantities. Vector quantities have numerical value. Like this has numerical value 5 Newton, this has numerical value 9 Newton. This force has numerical value 10.3 Newton. So the first is the numerical value and the second is direction. This force has got this direction. This force has got towards right. When you add them, then you get 14 Newton. These two, their resultant or their net force is this direction. So the direction can keep changing. The direction could be along x-axis, it could be along minus x-axis, or it could be any other direction. Is it clear? Again, I'll write this. Scalar. No direction. Only magnitude. Magnitude has another name, that is numerical value. Okay. Vector. What is the difference between vector and scalar? Also direction. Also direction. And magnitude. You are getting my point? Today here we are going to study vectors. And how they are added, how they are subtracted. One vector multiplied to other vector. One vector is divided by another vector. How vectors are written. Okay. All these things we will discuss. Now it is clear?
Okay, sir. Yes, sir. Yes, sir.
Represented by a straight line, rather by an arrow. Okay. A is the name of this arrow. This is vector A. Okay. This is vector B. This vector starts from P and it goes up to Q. This vector's name can be PQ. You are seeing these three lines. There is an arrow at the end of the line. So this is called tail and this is called tip and length. Length of vector is this, so much length. This point, it is like a arrow. So the arrow has got a last point, that is tail, and in the front there is an arrow, so that is called tip. Okay, is it clear?
Yes, sir.
Tip and the length. So its name is A, its name is B, its name is PQ. So you can give just one name. Here you can give just one name. And here you can give the name, the starting point which comes first and the final point comes second. and all are sent like this. Okay. Vector quantity is represented by a straight line.
Yes.
Arrow. This is a straight line and this is the arrow. Straight line and an arrow. The arrow end of arrow is called tip. The starting of arrow is called tail, and there is a length. So there are three things: tail, tip, and we can write one is positive, other is negative, but only when we say, you see, I'll come to that. For convenience, it is same as A vector is same, three lines same as A vector. This is a straight line, okay? Arrow is not there. It is the same thing. If you have to write the magnitude, then you can either show like this, or you can show like this, or you can show like this. That is magnitude. The full vector is shown like this, and magnitude is shown like this. So far, whatever we have discussed, is there any doubt? Only on this. Equal vectors. You see, they have same direction. If I write A is equal to B, that means A vector and B vector, they are the same thing. They are equal. A vector is equal to B vector, or say like this. Then A is equal to B and same direction. Understood? A and C are opposite and equal magnitude. Magnitude in short, I will be writing like this: M, A, G, and N. Okay? Equal magnitude. That means A is equal to C, or you can write A vector mod is equal to C vector mod. Magnitude is same, but the direction is opposite. How do you show them? You show them like this. C vector, A vector. C vector is minus A vector. Then they have equal magnitude. You can see the length of C and the length of A is equal. That means their magnitude is equal. What about the direction? Direction is opposite. You can see here. That opposite direction is shown by this minus sign, okay? If I write A is equal to minus C, that simply means that A and C are equal in magnitude and opposite in direction. Okay. If A is equal to 2 Newton along east, then C is equal to 2 Newton along west. This is going along east, then this is going along west. Acting along it, they are not going anywhere. Okay, so any doubt up to this? If you have any doubt, please tell me.
No, sir.
No.
I have a
Okay.
doubt.
Sir, if vector
Yes.
C and vector A are traveling in the same direction but with same magnitude, will they collide?
See, A is equal to minus C. That means A and C have opposite direction. Okay. And
Yeah.
if A is equal to B, then they have same direction. There is no other difference. A is equal to same direction. Here there is no negative sign. A is equal to minus C. That means they have opposite direction.
Okay. Okay.
Okay. You can
Yes.
say two vectors are equal. You can apply this equal sign only if the directions are either same or opposite. Say P is 5 Newton and Q is also 5 Newton. These quantities are force. Suppose I am showing you here, this is 5 Newton, this is 5 Newton. Can I write P is equal to Q or P is equal to minus Q? Can I write like this?
No, sir.
No, sir.
Wrong.
No, sir.
Cannot write, because whenever I give this equal sign, giving equal sign immediately it means that either the direction is same or the direction is opposite. Okay. So here what can I say? I can only say this, P is equal to Q. The magnitude is equal. I can say nothing more. Or P is equal to Q. They are the same thing. Magnitude. Their magnitudes are equal. This is also equal magnitudes. So whenever you write equal sign, it automatically it means that the directions are either same or opposite. So any doubt here?
No, sir.
Acha, I should be looking this way. You see, A is a vector. Very clear. A is a vector. You have shown an arrow. And AX is component of A along X direction. This is a vector, this is another vector. So what do they mean? This means A is this way. And if you want to know what is the effect of A in this direction, or see, I can write like this. AX AX is effective value of A along X direction. AX is equal to A cos theta. How do you get it? You simply take the tip. From tip you draw a perpendicular and it is meeting here. So this is AX. From here to here is AX. This much, okay? Effective value, that means A is acting in this direction. So A will have some effect along X direction. What is that effect? That effect is AX. How much is AX? AX is equal to A cos theta. AX and A cos theta, these are two different vectors, but their directions are not same. See, this is the direction of AX, this is direction of A. I cannot write like this, but I can write their magnitude. Okay? So this is wrong, this is right. This you are clear. Hypotenuse, perpendicular and base. So AX is the base here. I'll give an example. A is equal to 10 Newton. This is X direction. Theta is 60 degree. I apply 10 Newton this way. Is it clear? I'm applying 10 Newton this way. And what is the effective value of 10 Newton in direction of X? That effective value has got a name, AX. And what is the value? You see, AX is equal to A cos 60.
5
A is 10. Cos 60 is 1 by 2. That means 5 Newton. So component is just another component. It is just another value. Effective value. You change the direction, then it will change. Is it clear? Only this part.
Yes, sir.
I suppose it is clear because I am trying to go very slow. Anyway. Then rectangular components. अच्छा ये ओके ओके हाँ लेफ्ट का अंडू ठीक है देखेंगे वाला This is P cos theta, Py is P sin theta. I give a name Py. Py and Py, they are the same thing. Only direction has shifted. It has nothing has changed between this Py and this pi. Nothing has changed. So I can write this is P sin theta or this is P sin theta. That you can see here itself. triangle base is cos theta, perpendicular is sin theta, and this is hypotenuse. Okay. So Px and Py, then I will say, and they are called rectangular components. Why rectangular? Why they are called rectangular? See, they are making a rectangle like this. So we are saying rectangular component. Rectangular components means there are two components. These two components are perpendicular to each other. Then Px square plus Py square is equal to P cos theta whole square plus P sin theta whole square, that is P square cos square theta plus sin square theta, that is P square. So what you have got, which means Px square plus Py square is equal to P square. Relation number 1. So if you have got two components that are rectangular components, you take their square, it becomes magnitude of the original vector and squared. Okay. Then next, Py upon Px is equal to P sin theta divided by P cos theta. That becomes tan theta. So Py by Px is equal to tan theta. This is number 2. I told you in last class, whenever you say that there is a formula, this is a formula and this is also a formula. And I told you, formula is not sufficient. You should know under which condition this formula can be applied. Can we apply this always? No. We can apply this formula when rectangular components are taken. See, this is one rectangular component, this is another rectangular component. Then their square is equal to original vectors square. And if you take them, y component along x component, that is always tan theta. There could be other components also. So here it is clear.
Yes, sir.
So we'll have one
Yes, sir,
example
I need
here.
to copy down. I need to copy down.
Okay, okay. Example. You see here, theta you have made 60 degree. No, we don't know yet. We don't know. Come to this question. Two meter per second. Py is equal to 1 meter per second. You can call it Py or By, doesn't matter. See, I can give a name. Vy is 1, okay, 1 meter per second. Vy. This is V. This is Vx. Find Vx. Find theta. Okay. Just using these. Velocity 2 meter per second is along 60 degree with respect to east. So this is 60 degree. I have already done this. Theta I have done. This is 2 meter per second. What is Vy? Vy is equal to V sine theta. So 1 is equal to 2 60 degree. There is just application of this formula. Okay. Hmm. Hmm. So rectangular components you have seen. There could be other components also. You see, this is B vector. These are not rectangular components, not rectangular. Okay, there is no signs. Every time I have to write this. These are not rectangular components. See, rectangular comes only when this is making a rectangle. Theta is 70. Hmm. Theta is 70 degree. Then what? Yeah, still you can have components. See, the components will be BL. BL is equal to B cos 70 and BM is B cos 40. That's all. I'll put the value of cos 40 and I'll put the value of cos 70. So remember here, you can get components in any direction. You can get components in any two directions, but it is not necessary that the components will be rectangular components. So can you write like this? BL square plus BM square is equal to B square. Right or wrong?
Wrong.
Wrong, sir.
Wrong.
It is wrong. So you should be careful about rectangular components when you are applying those formulas. Can you write like this? BL upon BM is equal to some value, some tan theta. Okay? Can you write like this? BL upon BM is equal
No, sir.
to
No,
No,
sir.
sir.
cos 70. Can you write this? Cos
No.
70 upon cos 40.
No.
No, sir.
Yes, you can write. Cos
No, sir.
70 upon cos 40. You see, you do this upon this is equal to this upon this. B gone. Then cos 70 upon cos 40. But you cannot write tan 70. No. Can you write tan 40? No.
No.
Can you write cot 40?
No.
No. Okay. So I wanted to emphasize that in the beginning of your studies, today is the first class, you might be tempted to use that formula in every case. No, it is not true. Okay. So components you have learned very well. And I don't want to do anything more on components. Okay. Then addition of two vectors. If it is written like R is equal to A plus B, R is a vector, A is a vector, and B is also a vector. If I write like this, then it means A and B together produce some result. R produces same result. R is called addition of A and B, or vector sum. Addition of A and B, or vector sum of A and B, or resultant of A and B. It is like saying the same thing in two languages. Ram is son of Shyam, and Shyam is father of Ram. And Ram and Shyam, they are father and son duo. But basically it means whenever you write like this, what does it mean? It means this is language. It says R is resultant of A and B. Resultant, so R, word R is used. Or R will do the same thing. R will do the same thing which A and B together will do. A does something, B also does something separately. Then what is R? R is what they do together, R will do alone. Okay? Is it clear now?
Yes, sir.
Then how to find? So there is one parallelogram method. Parallelogram method. We will use a parallelogram. We will make a parallelogram. And from that parallelogram, we can get the value of R. You see here, I will write A like this. Okay. A vector I will write like this. And B vector I will like this. See, we are writing A vector and B vector together. They are starting from this point. Then I'll complete the parallelogram. So I'll write the steps. Okay. You see these steps first. Let A and B start from same point. Say O. This is O. So the first step is you bring them so that they will start from same point. First step. Okay. Next. Complete parallelogram. Parallelogram short. So A and B are there starting from the same point and you complete the parallelogram. Can you say this is A and this is B?
Yes, sir.
You can always say. So I need to write only two sides of the parallelogram. Other two sides are understood. Okay. Then there is a formula and I'll go to the derivation after this. Okay. So the formula is equations number 1 and 2. You see, this R is a third vector. This vector and this vector you have added. I will give you the conditions of vector addition. Right now, I am telling you what is magnitude of R. Okay. You know the magnitude of A and magnitude of B. That is given. Magnitude of A and B are given. So you want to know what is the magnitude of R. And you also want to know what is the direction of R. R is making angle beta. This is angle beta. R is making angle beta with respect to vector A. And then next, R is diagonal of this. So diagonal is clear. Okay. These two you should memorize as a formula because every time in vectors almost 50% of the times you will be using this formula. We will come to this formula. Half of this we'll discuss today and the remaining part or the remaining thing we will discuss in another class. So I am coming to this. See, if it is A, this is B, then what is? You see, parallelogram, I have put a perpendicular from here to this. This is vector A, this is vector B. This is a parallelogram and I am dropping a perpendicular on this line. The line is extended here. Okay. Then I'll do the derivation on this, whether it is B or A, whatever was there, leave it. Here it is like this. So this is R. Then R square is equal to R square is equal to this square plus this square. That means A sin theta whole square plus B plus A cos theta whole square. And that becomes A square sin square theta, and this is A square cos square theta. So that will become A square plus B square plus 2BA cos theta. Simple. That means R is equal to root of A square plus B square plus 2AB cos theta. This is one you have got. The other is you want beta. Okay. Beta is tan beta. Tan beta is what? Tan beta is perpendicular upon base. Perpendicular is A sin theta upon B plus A cos theta. That is number 2. If this is A here, A will come twice. B is here, B will become once. See, there's the strange thing, and you should be clear about it. In the result, beta angle is made by R with respect to vector B. Okay. This is vector B and this is beta angle. Then B will come only once, and the other vector will come on the top with sin theta and in the denominator with cos theta. I will take one example here. A is equal to 10 Newton and B is equal to 14 Newton. They act at 60 degree with respect to each other. What single force can replace both A and B? So single force is whenever we say a force, that means it's a vector. And a vector you can have to give both its direction as well as the magnitude. Direction is here. R is equal to root of A square B square 2AB cos theta. That means A is 10 square plus 14 square plus 2 into 10 into 14 into cos 60. Cos 60 is 1 by 2, so it gets cancelled. That is 100 plus 196 plus 140. So that is 296, 396, 436 is equal to root of 436, which is approximately 20.8 Newton. 436 is approximately 20.8 Newton. So you have got this one thing. You got the magnitude. Direction you go to tan beta. Tan beta is A sin theta and A is this. So A sin theta is 10. 10 into sin 60 divided by 14 plus 10 into cos 60. Cos 60 is 1 by 2. So this becomes 5 root 3 divided by 14 plus 5, 19. Okay. So that is 5 root 3 is approximately 0.866. 8.66 divided by 19 is approximately 0.45. Okay. So theta is beta. Beta is approximately 22 degrees. Oh yes, around 22, 20 degrees. Or say 22 degree. This value you have to go to the calculator or you have to go to the Multiplication tables like log tables, that's a separate thing that we will study separately. So beta is 22 degree. You see, beta is 22, theta is 60. Then what is this angle? 38 degree. 38 degree and 22 degree. So R is a resultant. R magnitude is 20.8 Newton and the direction of R is at 22 degree with respect to B. This is a simple formula. There are two-step formulas. Any doubt in understanding this?
No, sir.
Okay. So this we have given one example here. Special cases. Theta is equal to 0 degree. Theta equal to 180 to 180 degree. Third, theta equal to 90 degree. Theta 0 degree means A theta is 0 degree. A is acting this way. B is also acting this way. Then magnitude of R is equal to magnitude of A plus magnitude of B. Okay. I can also write similarly R is equal to A plus B. What does that mean? It means the value of R is the sum of the values of A and B. Direction is same. Direction of R is same as that of direction. That means R is this. Theta is 180 degree. A is this. These three special cases you will be facing always. First, two vectors are in same direction. You simply add them. This is A and this is B. So I will use this. You see, this is A and this is B. A is up to here, then B, and together it is R. So R magnitude is equal to A magnitude, B magnitude, and sign, direction you understand. If they are opposite direction, that is the problem. Then bigger is A. So this is R. I will do this in detail in triangle method. So right now, two method, theta 0 degree, you have this, theta 180 degree, you have this, and theta 90 degree is this. Cos theta, cos 90. If there is some doubt, don't worry. This doubt will get resolved. This doubt will soon get resolved. Okay? If you find there is any mistake or you think it's a mistake, tell me. Okay, we shall move on.